One of the things we're going to start taking a look at in this section is we're going to start looking at the idea of what a quadratic equation is. A quadratic equation is anything that has a square in it. Okay, so most of the equations that we've solved in the past have just the form ax plus b equals 0. All right, but if it's a quadratic, it has a square in it. So we're going to be taking a look at 3 different methods in this video series as to how to solve these quadratic equations. And one of the ways to do that is what we just learned in the previous section by factoring. What we're going to do is we're going to set the equation to 0. In fact, this is a good practice for almost all of the quadratics that we're going to be looking at. Okay, there's only one form that we don't do that with. We're going to factor the side that contains the polynomial, and then we're going to set each of the factors equal to 0 and solve. All right, so let's start off with a fairly easy example, and then we'll work our way up to some of the trinomial types. We have 2y squared equals 14y. Now, I'm going to show you the wrong way to do this because this is what a lot of students will do, is they say, okay, well, I'm going to divide both sides by 2y. And if they do that, they're going to get y equals 7, all right? And unfortunately, if you divide by a variable, you're going to lose a solution, all right? So most of the time, you never want to divide by a variable to solve an equation. So let me show you the correct way to try to do this by factoring. We're going to set this equal to 0 by subtracting 14y from both sides. So we're going to say 2y squared minus 14y equals 0. We can factor out a greatest common factor from this of 2y. Right? And if we divide everything by 2y, 2 divided by 2, y squared divided by y is going to leave us y. 14 divided by 2 is 7. Y divided by y is going to be nothing. And so we get 2y, y minus 7 equals 0. Now, we're going to set both of the factors. So that's step 1, set the equation to 0. Step 2, factor each side. Now we're going to set both of the factors equal to 0. So we're going to get 2y equals 0. Right? And if we divide that by 2, that produces the equation y equals 0, or the solution y equals 0. And then y minus 7 equals 0. We would just add 7 to the right-hand side, and this would produce a solution y equals 7. And we already knew that 7 was a solution, but remember we divided by 2y initially to solve the equation, not when we factored the GCF, and we lost that solution of y equals 0. So our solution set for this is going to be 0, 7. Right? Generally, when we solve a quadratic, we should get 2 solutions, okay? And sometimes they're not necessarily the prettiest solutions, but that's what we're going to deal with. A second example is a trinomial type. We're going to multiply. We're going to have 1 times 12, and that's going to give us 12. And we're looking for all the numbers that multiply to be 12, which is 1 times 12, 2 times 6, 3 times 4, right? And it looks like that if we add these together, the magic numbers are going to be 2 and 6 almost, right? Except that it's going to be a positive 8 and we need a negative 8, okay? So remember the trick that if everything's positive, you could still multiply 2 negatives together, all right? And the magic numbers are going to be -2 and -6 because they add up to a -8. All right, so now this is one trinomial that has a 1 as the coefficient. So if that's true, remember we can skip right to the answer and just write this as x minus 2, x minus 6 as the factored form. But that's not the solution. What we're going to have to do is we're going to have to incorporate this into the quadratic equation here. Okay, so what we're going to do is we're going to say that by factoring x minus 2, x minus 6 equals 0. And then what we're going to do is we're going to set each of those factors equal to 0. All right, so we still have more steps after factoring. So one solution is obtained by adding 2, the other one obtained by adding 6 to both sides. So we're going to get x equals 2, and we're going to get x equals 6. And our solution set is going to be x equals the set 2, 6. All right. One final example of a trinomial. Now this one's sneaky. X squared equals 2x plus 35 because it's not set equal to 0. One of the types of hints I would suggest is keeping the square positive. All right, so keep the square where it is and just move everything else over to the square if it's positive, and if it's not positive, make it positive by adding it to the other side. And so we're going to subtract 2x, and we're going to subtract 35, and we're going to write it in descending order according to the powers of x. All right, so when we rewrite this, we're going to write this as x squared minus 2x minus 35 is 0. We're going to look at negative 35. So we take 1 times negative 35. That's negative 35. We're going to go down our list. So negative 1 times 35. Negative 3 doesn't work. 4 doesn't work. 5 works. And that's really close because if we add those together, that gives us 2. So we're just going to flip it around. And these are going to be our 2 magic numbers. Remembering, because there's a 1 in front of the x squared, we can just jump right away to x plus 5, x minus 7. And then we can incorporate that into the quadratic equation here. So it's going to be x plus 5, x minus 7 equals 0. By factoring that out, we're going to set x plus 5 to 0. We're going to set x minus 7 to 0. We're going to subtract 5. We're going to add 7. And we're going to have x equal negative 5 and x equal positive 7. And so our solution set for this is going to be that x equals the set negative 5, positive 7. Right. Another type of doing these solutions to our quadratics is one special type we use something called the square root principle. Now, the square root principle we have to be careful with because it can only be used if we have the form x squared equals a. All right, so in other words, x squared is equal to some sort of constant, then we can go ahead and set it equal to plus or minus a. All right, square root of that. So let's just take a look at a couple of really easy examples of this. All right, so we have x squared minus 9. We're going to put it in the form x squared equals a by adding 9 to both sides. All right, so now in the other problems, remember we had like this linear term in here. So we had a 2x and we had a negative 8x and we had a 14y. Anytime you have like a first power of x or y or something like that, you can't use the square root principle. All right, or in fact, it's probably not going to be too useful to you. But in this case, we can write this as x squared equals 9. We're going to take the square root of both sides. And so we know that the square root of x squared is going to be x. The square root of 9 is 3. And the square root principle tells us to put a plus or minus in front of it. Right? Now, we could have gotten this by factoring. Remember, this is a difference of squares. So we could write it as x plus 3, x minus 3, or x minus 3, x plus 3. We'd say x minus 3 equals 0, and then x plus 3 equals 0. And so we would add 3 to both sides. So x is 3, x is negative 3. And so our solution set would be 3, negative 3, all right, by factoring, if we wanted to do it that way. But this is a lot quicker, okay? So notice we literally use like 2 or 3 steps. So the square root principle is very useful in those situations, okay? Not saying it's always useful, but this is a pretty good one. Another example of the square root principle, we have 5x squared equals 125. Let's start by dividing both sides by 5 to isolate the x squared. All right, so we need it of the form x squared, or 1x squared is equal to a. All right, so if we divide both sides by 5, we get that x squared equals 25. And now we can take the square root of both sides. So x is going to be equal to plus or minus 5, and we're done. All right. Again, we could factor this if we were to take the 25 on the left-hand side, but this is much faster. In our next video, what we're going to do is we're going to go ahead and use our final method of being able to solve quadratics, which is going to be the quadratic formula.